principal component analysis. Principal components, also known as PCA when we look at principal components analysis, are linear components of the original variables. And what they try to do is capture as much variance as possible in a data set. So what we need to know about principal components is that they're summary variables. And what that means is they're trying to summarize or represent another group of variables. So let's say that you were taking a survey at your workplace in regards to satisfaction with your job. Now you may be asked, how satisfied are you with your job? But in addition, you may be asked questions like, how satisfied are you with your manager? How satisfied are you with organizational culture? How satisfied are you with room for growth? And what principal components do is they try to say, hey, all of these things are related to on-the-job satisfaction. And so we can create a composite score of these variables to represent on-the-job satisfaction in total. So they're formed by the linear combination of the original variables. So if there were 5 original variables, now we just have that one factor, that one component, which is a data reduction, saying, okay, instead of asking these 5, these 10, these 20 questions about job satisfaction, we find out that are you satisfied with your manager is the best predictor of overall job satisfaction. Now these variables are not allowed to be correlated with one another. They're known as orthogonal. And the factors themselves try to capture the maximum variance within themselves. So now we could ask a single question instead of 20 questions, and the accuracy may be slightly lower, but it also means that the survey is extremely shorter, and now we get more survey responses. So principal components analysis is this process of extracting variables from a data set to explain the maximum variance of the variables in that data set. So we end up not using the original variables, we use these components to represent those original variables. So if we had n independent variables in a data set, PCA may extract k new variables that explain the most variance in the data set. So where may PCA be used? Well, it could be used to eliminate duplicate variables in cases where many variables are present in the data set to avoid redundancy. This is quite common with gene sequencing because there's often 20,000 or so gene sequences. And so if some can better represent the majority, then there's less inputted into the model. And since there's no dependent variable, we're not trying to necessarily predict anything with PCA. This model is known as, or categorized as, an unsupervised learning model.